Excellent. Well, thank you very much for inviting me, and thank you very much for asking us to talk about Renishaw today. Clearly, there's an awful lot going on in the world, and this is an unusual situation for everybody. So I'm speaking to you from my kitchen/office, and looking forward to telling you a little bit about what Renishaw does. Okay. So clearly, let's address the elephant in the room. This COVID situation has got everybody on the back foot at the moment, and it's encouraging, heartening, and exciting to see the ways that people are reacting and the things that the world is doing to respond. And it's nice to see that in additive and manufacturing in general, we're seeing companies from all walks of life coming together and contributing. So a quick word on how Renishaw is joining in with that. So, as many people will know, Renishaw has quite a bit of history in the medical field, and we've been joining up with a number of partners in a consortium in the UK in particular, along with companies such as Airbus, Mercedes, F1, in the production of high precision ventilator equipment. A lot of this is very high quality, very high accuracy requirement machined components. And there's a deal of metal additive work going on as well in prototyping and very small production pieces. So to get, kind of more on track of what I was kind of planning to talk about today in more detail. So again, many people are familiar with the name Renishaw, founded way back in 1973. So we're getting on for 50 years old. Fairly large company, 4,000 employees. Perhaps most famously, we're known for our world-leading metrology products. Very often when we're at trade shows focused on additive, we're having people coming up to us and asking if we're the probe guys. And interestingly, the last Rapid show, we had people coming up to us and saying they didn't realize that we did metrology stuff. So it's curious how these things change over time. But really what I would say today is our core competencies have grown and developed over time to perhaps be described more generally as process control, automation, and really a customer-centric, application-driven support approach to helping customers. And indeed, our founder, Sir David McMurtry, when he set up the company, one of his guiding principles was this idea of having knowledgeable, skilled, and experienced support staff based locally in each market. And to that effect, as a UK company, we initially grew out our presence in the EU, but that has spread over the years to all around the world. In fact, we've got over 80 offices in 36 different countries. But all of our products are proudly made in the United Kingdom. So that has never changed during the history of the company. And it's something we take considerable pride in, especially to this day with a lot of what's going on. So talking about who our customers are. So our customers, regardless of the product line, so whether we're talking about additive, metrology, whatever it may be, they're coming from all walks of life, all kinds of industry sectors that our modern economies rely on. And, in the face of what's going on now, we could even suggest that the companies that are going to pull us out the other side of this are going to be, many of whom are already our customers. And, we can foresee demand for innovative products in additive, for products in, machine calibration or CNC measurement to increase productivity and quality of things that we're doing. So the focus of today obviously is going to be more on the additive product lines. So in particular, I'm going to be focusing on our hardware systems, our software products, but I'll touch also a little bit on our solutions end of things as well in terms of our support and in terms of what we're doing online as well. So one thing that's important is that we don't see additive as just being an island product of Renishaw's, totally different to everything else we do. One thing that people kind of throw at Renishaw is this idea that we got into additive as a bit of fun or, as a bit cynical, but it's really not the case. Really, additive, we see it as forming part of a larger family tree of products, all geared towards and all determined to provide innovative manufacturing technology enablers. So whether that's, increasing the throughput of CMM machines, increasing the accuracy and precision of your CNC machines, or indeed increasing the capability, productivity, and quality of your additive manufacturing technologies. So let's, without further ado, move on to looking at our hardware. So when we're talking about our hardware, the flagship system that we have is our 500Q. It's a 4-laser system, a quad system. And really it was developed around 6 guiding principles, those being safety, quality, productivity, repeatability, scalability, but critically, economically. So this system had to be developed in such a way that we're putting in all of this technology, but it's still an economic machine. So whether that be just purely in the price of the machine, in the amount of space it takes up, materials it consumes, whatever metric you want to talk about, okay? The whole development of this machine was aimed squarely at the melt pool dynamics. And what do I mean by that? Well, it's developing every subsystem of the machine to provide the best quality atmosphere, surroundings, and control of the melt pool when we're depositing powder, focusing and driving the lasers, but also handling that powder within the footprint of the machine. So we're talking about a 250 mil square machine by 350 mil height. So it's a mid-range size machine. We're talking about intelligent gas flow. So what does that mean? Well, it's high volumetric flow. It's being careful how that flow is distributed through the machine. So whether that be the knife running across the bed or the shield running in front of the actual laser window. But it's also making sure that we ensure processing consistency at the melt pool by removing all of that condensate and that spatter. Okay, controlled powder management. So within the footprint of the machine, we are sieving and recycling the powder. So it's totally under inert atmosphere at all times. We're not having to introduce further risk there. Also simplifying usability of the machine. We've got high precision dynamic optical control, so a patented Renishaw system enabling all 4 lasers to address the whole bed stitch free, which is something I can perhaps get into in a Q&A. And then connected and intelligent sensing technologies. So incorporating all of that history of optical measurement knowledge and utilization of lasers in calibrations and machines and all that kind of stuff, actually in the in-processing monitoring technology on our additive manufacturing machines. So again, just a couple of highlight points. So obviously Renishaw's been around for 45 years, 45 plus years coming on. So we've got a lot of manufacturing experience and a lot of technology stack. And the key thing is that we base everything we do on our own IP. We want to maintain as much independence and as much control over the quality standards that we possibly can. And a lot of the data that we generate around the queue, whether that be repeatability or throughput, is actually published online as well. So we're very open in terms of what we're doing and how we believe that brings a number of benefits to the world. So in terms of our software, we are keen to provide solutions for the entire end-to-end process. And a big part of that is the build setup software. So we have our own bespoke tool that's generated specifically for Renishaw machines, and it contains all of the tools required to configure and set up a build or develop new materials within a single tool set. And it doesn't contain any additional tools that may be considered bloatware, for example, where you have software tools that contain settings for metal and plastic printing, for example. So that's a real important tool. And critically, in the most modern machine platforms, we've got all of the tools there for laser assignment, but also understanding the efficacy and the efficiency of how we are assigning those lasers. In terms of the process monitoring, we have ultra high resolution hardware. So actually we're capturing data at extremely high resolutions and extremely high sample rates. And we have the ability, by developing our own software, to handle that in the ways and means that we feel most beneficial and most effective by our end users. So we see it as effectively being a kind of digital in-process instant gauging technology, comparing one build to another. And it's a real do-it-yourself approach that is applied throughout our entire additive program. Okay. And then the third arm of our software product line would actually be Renishaw Central. So here what we're doing is actually providing a production monitoring system that goes far beyond just the additive machine. It also incorporates the entire remit of where Renishaw products may touch a manufacturing process. So whether that's managing or monitoring the throughput of CMM systems, CNC systems, or our digital gauge systems, what we're offering here is the ability for an end user to actually evaluate and understand the entire manufacturing flow and actually understand any bottlenecks, or at least identify bottlenecks, and then drill down further into data that's being generated by these machine platforms and really get a good holistic understanding of what is going on there. Okay. So I mentioned that services are a big part of what we do, and it's not just in terms of when we have a customer come through the door interested in buying a machine, it's also in terms of servicing the wider industry and trying to share that knowledge wherever we feasibly can, wherever we possibly can. And so to that end, we have the AM Guide, which is a important part of our website, and I've had the pleasure and fortune of being able to contribute to this in quite a big way. So whether that be through the production of feature articles or case studies, you know, a number of case studies that I've been involved with, whether it be hydraulics, aerospace stuff, industry news, you know, we're keen to see the entire additive industry grow because it's better for everybody, but also putting out opinion pieces. So additive is an industry around which there is an awful lot of hype, and I think sometimes it's important that there are people out there cutting through some of that hype and actually asking some difficult questions, and that's something that at Renishaw we don't tend to shy away from. And it's something that I think increasingly, especially as we come out of this situation and everybody is readdressing manufacturing, how we're doing things, the supply chains we work within, and the approaches that we have to these technologies, you know, we need to really open our eyes somewhat, I think, and reevaluate moving forward. So in terms of prepared material, that's what I've got for you today. I'd love to open up the floor to some Q&A if anybody has any questions.
All right, thank you, Kevin. Let's stop sharing your screen. Anyone have any questions? I have not gotten any so far, but I'm wondering, oh, we've got one from Stephen Anderson. Partial talked about needing to crunch terabytes of data, potentially even petabytes of data. What sort of data is generated by process monitoring solutions?
Okay, so there's two streams of data that we can potentially be dealing with. So the first stream would actually be optical sensing on the machine itself, so actually monitoring the melt pool. On Renishaw systems, each laser has 3 channels of data that it can capture, one of which is dedicated to the laser itself and understanding the power received at the bed versus what was demanded, but also 2 sensors dedicated to measuring different wavelengths of light emitted from the melt pool. That in itself generates terabytes of data, and trying to understand and utilize that data in an effective way is something that the entire industry is still kind of scratching its head around, really, because there is so much produced. Are we supposed to keep it indefinitely? So Renishaw's approach has really been to think, well, what about if we just use the old metrology trick of gauging and comparing one data set on the fly to a known good standard data set, rather than trying to absolutely measure every single data set that is produced. The other stream, to round out the answer of data that gets produced, is from all of the myriad sensors across the machine: pressure, temperature, volumetric flow. What do we do with that information? I mean, we can look at that live and we can look at it retrospectively. And again, it's about marrying the data sets together in an efficient manner. So Renishaw Central, for example, could be used to produce the document that lives with, you know, a particular serial number, for example, for the remainder of its life.